This is the EdExcel A-Level Maths Paper 2, covering the pure maths content, and it's from the June 2018 series. Question number 1. We are given that g of x is equal to 2x plus 5 over x minus 3, where x is greater or equal to 5, and for part A we have to find g of 5. For part A, we can begin by finding out what g of 5 is. And if I find out what g of 5 is, I have 2 times by 5 plus 5 divided by 5 subtract 3. 10 plus 5 is 15, and I'm dividing this by 2, so I have 15 over 2 for g of 5. And so therefore, g of 5, we replace the x with 15 over 2. So we have 2 multiplied by 15 over 2 plus 5 divided by 15 over 2 subtract 3. So if I work out what this is, if I substitute in 15 over 2 into my calculator, then I've got 2 times by this plus 5 divided by this minus 3. So it turns out g of 5 is equal to 40 over 9. Then for part B, we have to state the range of g. Now, we know from the question x is greater or equal to 5. So, we know that when x is equal to 15, when x is equal to 5, g of 5, as we worked out previously, that's 15 over 2. And so this essentially is our lower limit, and to find our upper limit, we see what happens when x gets very large. We see what happens as x tends towards infinity of 2x plus 5 over x minus 3. And if I work this out, I've got the limit as x tends towards infinity. Now 2x plus 5 over x minus 3, I can divide the top and bottom by x. So I've got 2 plus 5 over x divided by 1 subtract 3 over x. And as x gets very large, 5 over x and 3 over x tends towards 0. And so what we will be left with over here is 2 over 1, which is just 2. So this is where the horizontal asymptote is. And therefore, for our solution, we've got 2, which is less than g of x, which is less than or equal to 15 over 2. And here we have a visual representation of the curve g of x. Then for part C, we have to find the inverse of g, stating its domain. Well, our first step would be to replace g of x with y. So we have y equals 2x plus 5 divided by x minus 3. Our next step is to rearrange for x. So if I multiply both sides by x minus 3, then we have y multiplied by x minus 3 equals 2x plus 5. So I've got xy subtract 3y equals 2x plus 5. If I gather everything with an x on one side, everything that's not an x on the other side, we have xy subtract 2x equals 3y plus 5. And if I factorize out an x, I have x multiplied by y subtract 2, and that's equal to 3y plus 5. And so therefore, x is equal to 3y plus 5 over y minus 2. Our next step is to swap the x and y, and if I do that, I have y equals 3x plus 5 over x minus 2. And then my next step would be to replace y with g inverse. So, doing so, g inverse, that's equal to 3x plus 5 divided by x minus 2. Now, when we come to state the domain of the inverse of g, you'd find the domain of the inverse of g is the range of g. So, if I go back to part B, we use x instead of g of x because this is the range. The limits will be the same, but this time, because we're considering the domain, it's in terms of x. So we have 2, which is less than x, which is less than or equal to 15 over 2. Question number 2. Relative to a fixed origin O, the point A has position vector 2i plus 3j minus 4k, and the point B has position vector 4i minus 2j plus 3k, and the point C has position vector ai plus 5j minus 2k, where a is a constant which is less than 0, and D is the point such that AB equals BD, and we have to find the position vector of D. Well, for part A of the question, I know that the vector OA is equal to 2i plus 3j minus 4k. I know the vector OB that's equal to 4i minus 2j plus 3k, and the vector OC that's equal to ai plus 5j minus 2k. And what we can do is find out what the vector AB is. The vector AB is equal to the vector OB subtract the vector OA. So I've got the vector OB, which is this vector here, and from this I subtract the vector OA, which is this vector here. And working this out, it turns out we get 2i minus 5j plus 7k. So that's the vector AB. And the vector BD, that will equal the vector OD subtract the vector OB. So I've got the vector OD subtract the vector OB. Now the vector OB, that is this vector here, and the result of this will equal AB, and that's because of this over here. And so what we need to do is find out what OD is. So, to find out what OD is, that will equal this vector here plus this vector here. And when we work this out, it turns out we get 6i minus 7j plus 10k. So that's the vector OD. Now for part B, we're given that the magnitude of the vector AC is 4 and we have to find the value of A. So for part B, we've got the vector AC, which is equal to OC subtract OA. So I've got the vector OC, which is this vector here, and then I subtract the vector OA, which is this vector here. And when we work this out, well, in terms of the i's, I've got A minus 2. In terms of the j's, I've got 2 of them. And in terms of the k's, I've got 2k of them. So that's what the vector AC is. Now I know that the magnitude of AC, that's equal to 4. Now how do I find the magnitude of a vector? I square each of the components and then add them together and then square root. So I've got A subtract 2 squared plus 2 squared plus 2 squared and then square rooted. That's equal to 4. Square both sides. We have A subtract 2 squared plus 4 plus another 4, so that's the same as adding 8. And that's equal to the square of 4, which is 16. Now let's solve for A. If I subtract 8 from both sides and then square root and then add 2 to both sides, A is equal to 2 plus minus the square root of 2. And so therefore our solution for A is 2 subtract square root 2, and that's because A is less than 0. Question number 3 for part A. If m and n are irrational numbers, where m doesn't equal n, then mn is also irrational. We have to disprove this statement by means of a counterexample. Well, for part A, let's suppose m is root 2 and n is root 8. These are both irrational numbers. And if I find the product, mn, that's going to equal root 2 times root 8, which is the same as root 16, which is 4. And 4 over here is not irrational, and therefore the statement is not true. Then for part B, for the first part we have to sketch the graph of y equals mod of x plus 3. Now when we come to sketch this graph, what we can do is, first of all, consider the graph of y equals x plus 3. So if I have a set of axes such as the one here, and if I was to sketch the graph of y equals x plus 3, it would look something like this. We've got the graph y equals x plus 3, it crosses here at 3 and it crosses here at negative 3. So when I come to sketch the graph of mod of x plus 3, we've got the graph of mod x, which is being shifted up by 3 units. So that graph would have this graph over here, y equals mod of x plus 3, and that's what we needed to sketch. And then for the next part we have to explain why the mod of x plus 3 is greater or equal to x plus 3 all modded for all real values of x. Well, to do this problem, let's first of all sketch the graph of y equals x plus 3 all modded. We need to reflect the red graph in the positive x-axis. So we have this graph over here, which is y equals mod of x plus 3. So when we come to explain why mod of x plus 3 is greater or equal to x plus 3 all modded, well, what we can say is, for x being greater or equal to 0, the mod of x plus 3 is equal to x plus 3 all modded. In other words, both graphs are equal. And if we take a look at the graph for values of x being less than 0, we see that the blue graph is greater than the green graph. This graph is greater than this graph. So, for x being less than 0, the mod of x plus 3 is greater than x plus 3 all modded. And so therefore we can conclude the mod of x plus 3 is greater or equal to x plus 3 modded for x belonging to a set of real numbers. Question number 4, for the first part we have to show that the sum from r equals 1 to r equals 16 of 3 plus 5r plus 2 to the power of r is equal to 131,798. So for the first part, we can write the sum from r equals 1 to r equals 16 of 3 plus 5r plus 2 to the power of r as the sum from r equals 1 to r equals 16 of 3 plus 5r plus the sum from r equals 1 to r equals 16 of 2 to the power of r. Now, let's focus on each of these bits separately. What we can do to find out the sum from r equals 1 to r equals 16 of 3 plus 5r is use the result here. For an arithmetic series, the sum of the series is given by 1/2 n times by a times by l. We've got 1/2 times by the number of terms times by the sum of the first term and the last term. So, if we focus on what we have here, when r equals 1, we have 3 plus 5 times by 1, which is 8. And so therefore, the first term is equal to 8. And when r equals 16, we have 3 plus 5 times by 16, which is 83. The last term, L, is 83. If we focus on what we have here, when r equals 1, we have 2 to the power of 1, which is 2. Here we've got a geometric series, and for a geometric series, we've got the sum equaling 1 times 1 minus r to the n over 1 minus r. So our first term, a, is 2, and our common ratio is 2, and the number of terms we have is 16. And so therefore, using those results which we mentioned, we have n over 2, so we've got 16 terms, so we've got 16 over 2 times by 8 plus 83 plus 2 times by 1 minus 2 to the 16 divided by 1 minus 2. And so if we work this out, we can use our calculator at this stage. We have 16 over 2 multiplied by 8 plus 83, and then we add on to this 2 multiplied by 1 minus 2 to the 16 divided by 1 minus 2. It turns out we get 131,798. And that's exactly what we wanted to show. And then for part B, a sequence u1, u2, u3, etc. is defined by un plus 1 equals 1 over un, with u1 equaling 2/3, and with this we have to find the exact value of the sum of ur from r equals 1 to r equals 100. Well, what we know so far is u1 equals 2/3, u2, that will equal 1 over u1, so I've got 1 over 2/3, which is 3 over 2, and u3 is 1 over u2, so I have 1 over 3 over 2, which is 2/3. And can you see how we're going to continuously cycle back? So if I work out what u4 is, that's equal to 1 over u3. So I've got 1 over u3, which is 2/3, which is 3 over 2. And so therefore, u odd, that's equal to 2/3. So u1, u3, u5, etc. that's 2/3. And u even, that will equal 3 over 2, so that's u2, u4, u6, etc. Now, from r equals 1 to r equals 100, we have 50 odd terms and 50 even terms. So, the sum from r equals 1 to r equals 100 of ur, we have 50 odd terms, and we also have 50 even terms. So I have 50 times by 2/3 plus 50 times by 3 over 2. And it turns out when we work that out, we get 325 over 3. Question number 5. The equation 2x cubed plus x squared minus 1 equals 0 has exactly one root. For part A, we have to show that for this equation, the Newton-Raphson formula can be written xn plus 1 equals 4xn cubed plus xn squared plus 1 over 6n squared plus 2xn. Well, here is the formula for Newton-Raphson. When we are solving f of x equals 0, we need f of x and we need f dash of x. So for part A, we begin by letting f of x equal 2x cubed plus x squared subtract 1. And so therefore, if I differentiate, I end up with 6x squared plus 2x. And using Newton-Rafton's formula, xn plus 1 is equal to xn subtract. Now here we've got f over f dash. So I subtract 2xn cubed plus xn squared minus 1 over 6xn squared plus 2xn. And we can combine this, so we've got one denominator of 6n squared plus 2xn. So I've got xn multiplied by 6xn squared plus 2xn subtract 2xn cubed plus xn squared minus 1. And then on the bottom over here, we have 6xn squared plus 2xn. So, expanding, I've got 6xn cubed plus 2xn squared, subtract 2xn cubed, subtract xn squared plus 1, and then I divide this by 6xn squared plus 2xn. So if I simplify, I've got 4xn cubed plus xn squared plus 1 divided by 6xn squared plus 2xn. And that's exactly what I wanted to show. And then for part B, using our formula given in part A with x1 equaling 1, we have to find the value of x2 and x3. Well, we know for part B, x1 is equal to 1. So, x2, that will equal 4x1 cubed plus x1 squared plus 1 divided by 6x1 squared plus 2x1. So I've got 4 times by 1 cubed plus 1 squared plus 1 divided by 6 times 1 squared plus 2 times by 1. And if I work out what this is, it turns out, if I write this as a decimal, we end up with 0.75. And x3, I've got 4x2 cubed plus x2 squared plus 1 divided by 6x2 squared plus 2x2. So I've got 4 times 0.75 plus 0.75 squared plus 1. And then I divide this by 6 times 0.75 squared plus 2 times by 0.75. And it turns out here we get 2/3. So we have the value of x1, x2 and x3. Then, for part C, we have to explain why for this question the Newton-Raphson method cannot be used with x1 equaling 0. Well, if I substitute in 0 with the top and the bottom for part C, if I substitute in 0 for f, I have 2 times by 0 cubed plus 0 squared minus 1, and that's minus 1. And if I work out f dash of 0, then we've got 6 times by 0 squared plus 2 times by 0, which is 0. And because f dash is 0, we can therefore conclude we've got a stationary point, and therefore the formula does not converge. Question number 6. F of x is equal to negative 3x cubed plus 8x squared subtract 9x plus 10, where x belongs to a set of real numbers. And for part A, for the first part, we have to calculate f of 2. Well, to calculate f of 2, we need to substitute in x equals 2 into f of x. So, for the first part of part A, f of 2 is equal to negative 3 times 2 cubed plus 8 multiplied by 2 squared subtract negative 9 multiplied by 2 plus 10. And if we work this out, we get 0. And now we have to write f of x as a product of two algebraic factors. Well, we see that f of 2 is equal to 0. And because of that, x minus 2 is a factor of f of x. So what we need to do now is rewrite this result as the product of two algebraic factors. So for that, I've got my linear factor x minus 2 multiplied by some quadratic factor ax squared plus bx plus c. This gives my cubic negative 3x cubed plus 8x squared subtract 9x plus 10. And what we need to do is find out what a, b and c are, and then we would find two algebraic factors, the linear factor and the quadratic factor. Now to find out what a, b and c are, we can compare coefficients. So if I compare coefficients, let's take a look at the x cubes. What gives us an x cubed? Well, I've got x multiplied by ax squared. That gives an x cubed. And on the right hand side, I've got negative 3x cubed. So in terms of the coefficients, we would have a equals negative 3. So a equals negative 3. If we compare the x squareds, what would give an x squared? Well, I've got here on the right hand side 8x squared, and on the left hand side I've got bx times by the x, and I also have the negative 2 times by the ax squared. So we've got b subtract 2a equals 8. We know what a is, that's negative 3. So I've got b subtract 2 times by negative 3 equals 8. B is equal to 2. And if we compare the number terms, Well, we have negative 2 times by c, and that would give the 10. So when we compare the number terms, we have negative 2c equals 10, in which case we see c is equal to negative 5. So how does this help us? Well, now that we know what a, b and c are, we can replace a, b and c here, and we can therefore conclude f of x is equal to x minus 2 multiplied by negative 3x squared plus 2x subtract 5. We have a linear factor and a quadratic factor. And then we have to use our answer to the second part of part A to prove that there are exactly two real solutions to the equation negative 3y to the 6 plus 8y to the 4 subtract negative y squared plus 10 equals 0. Now, what we'll do is we'll call this equation 1, and we'll call this equation here 2. Now, if we rewrite equation 2 for part B, from equation 2, we can rewrite that as negative 3 y squared cubed plus 8 y squared squared subtract negative 9 y squared plus 10 equals 0. Call this equation 3. And the reason I want to do that is because if I compare equation 1 with equation 3, we can straight away see that x is equal to y squared. So, if we let x equal y squared, then equation 3 would become equation 1. And if that's the case, we are solving, rather, if that's the case, then what we are solving then is negative 3 x cubed plus 8 x squared subtract 9x plus 10 equals 0. And so we are solving this equation. And if we use our result to the second part of part A, we wrote this as x minus 2 times by negative 3x squared plus 2x subtract 5 equals 0. And so we have x equals 2, or we've got negative 3x squared plus 2x subtract 5 equals 0. Or rather, we've got x minus 2 equals 0. And negative 3x squared plus 2x minus 5 equals 0. And so from here, we can see x is equal to negative 2. Now from here, what we can do is use the discriminant. And if I use the discriminant, I've got b squared minus 4ac. I've got 2 squared subtract 4 times negative 3 times negative 5. And that's negative 56. And because the discriminant is less than 0, for this quadratic equation, we can therefore see we've got no real roots. And because we've got no real roots then, that means this x equals 2 is the only real solution. And if x equals 2 is our only real solution, and we know that x is equal to y squared, we can then say, as x equals y squared is equal to 2, and so therefore y is equal to plus minus square root 2. Question part C, we have to deduce the number of real solutions for theta being in between 7 pi and 10 pi to the equation 3 tan cubed theta subtract 8 tan squared theta plus 9 tan theta minus 10 equals 0. So for part C, we have our equation 3 tan cubed subtract 8 tan squared plus 9 tan theta minus 10 equals 0. And what we will do is, this time we will let x equal tan theta, and if we do that, we've got 3x cubed subtract 8x squared plus 9x minus 10 equals 0. And if I compare this with what I was solving over here, what I can do is multiply this by negative 1, leaving me with negative 3x cubed plus 8x squared subtract negative 9x plus 10 equals 0. And what we know from part B, x equals 2 is the only real solution to this equation here. And because x is equal to tan theta, that means we are solving the equation tan theta equals 2. We're seeing how many solutions this has between 7 pi and 10 pi. And what we'll do is we'll draw the tan graph. So we've got our tan graph in between 7 pi and 10 pi. And if I draw the line y equals 2, that is over here, and so from here we see that we've got 3 solutions, theta 1, theta 2 and theta 3. So therefore we've got 3 real solutions only. Question number 7. For the first part, we have to solve for x being in between 0 and pi over 2, the equation 4 sin x equals sec x. So for the first part, we begin with 4 sin x equaling sec x, and we are solving this in the domain 0 to pi over 2. Now sec x is the same as 1 over cos x. So we have the equation for sin x equals 1 over cos x. And if I multiply both sides by cos x, we have 4 sin x cos x equals 1. And we can rewrite this as 2 times by 2 sin x cos x equals 1. And the reason we want to do this is because we can recognize 2 sine x cos x is the same as sine 2x. So I've got 2 sine 2x equals 1. And so sine 2x is equal to 1/2. Now, our normal domain is from 0 to pi over 2. We don't have an x, instead we've got a 2x. So our next step would be to change the domain. And if I change the domain, I have 0 to 2x to pi. And so if I solve sine 2x equals 1/2, well, 2x will equal pi over 6, and the next value, pi take away pi over 6, which is 5 pi over 6. And so therefore x is equal to pi over 12, 5 pi over 12. Here are our solutions. Next, we have to solve for theta being in between 0 and 360, the equation 5 sine theta minus 5 cos theta equals 2, giving the answer to 1 decimal place. So, for the next part, we begin with 5 sine theta subtract 5 cos theta equaling 2. Now, the left hand side is of the form r sine of theta minus alpha, and if we go to the formula book, under the trig section, we will be using this identity here. So the left hand side is of the form r sine of theta minus alpha, which is equivalent to r sine theta sine alpha, rather r sine theta cos alpha minus r cos theta sine alpha. And so if I focus on the left hand side, we have 5 sine theta minus 5 cos theta. What we are saying that is the same as, well, if I write it out, I've got 5 sine theta minus 5 cos theta, which is equivalent to r sine theta cos alpha minus r cos theta sine alpha. And if I compare, well, if we take a look at the sine thetas, I've got 5 of them on the left hand side, and on the right hand side I've got r sine theta cos alpha. So comparing the sine thetas, I've got 5 equals r cos alpha, and now if I compare the cos thetas, I've got 5 of them on the left hand side and r sine of them on the right hand side. So comparing the cos thetas, we have 5 equals r sine alpha. And so dividing these equations by each other, sine alpha divided by cos alpha is tan alpha, and the r's cancel, and 5 divided by 5 is 1. tan alpha is 1, alpha is 45 degrees. And if I find out the value of r is equal to 5 squared plus 5 squared square rooted, which is the same as the square root of 50. And so therefore, I can rewrite the left-hand side of this equation as 50 square rooted times by sine of theta minus 45, that's equal to 2. So, sine of theta minus 45 is equal to 2 divided by root 50. So, theta minus 45, I'm solving this in between 0 and 360. So let's write out our new domain. The new domain, I've got negative 45, which is less than or equal to theta subtract 45, which is less than 360 take away 45, which is 315. So I need to find out the values of theta minus 45 in this domain. So I've got the inverse sine of 2 over root 50, which is 16.429. And to find out the next value, I need to do 180 minus this, so I get 163.57, etc. And then with these values I need to add 45, so I've got this plus 45, so theta is equal to 61.4, and the next value I get 208.6 degrees, and this is given to 1 decimal place. Question number 8. Figure 1 is a graph showing the trajectory of a rugby ball. The height of the ball above the ground h meters has been plotted against the horizontal distance x meters measured from the point where the ball was kicked. The ball travels in a vertical plane. The ball reaches a maximum height of 12 meters and hits the ground at a point 40 meters from where it was kicked. For part A, we have to find a quadratic equation linking h with x that models this situation. Well, what do we know so far? We know so far that it reaches a maximum height of 12 meters over here and it hits the ground again 40 meters from where it was hit. So here, if I was to add on the coordinates, I've got 40 across 0 up here. Here I've got the origin, and through symmetry, this point will be 20 because it's half the 40, and then it reaches a maximum height of 12, so the y-coordinate is 12. And so, with our roots being at 0 and 40, for part A, the modulus of the form h equals kx times by x minus 40. And we know that when x is 20, h is 12, that's the maximum height. So, when x is equal to 12, rather when x is equal to 20, h is equal to 12, so I have 12 equals k times by 20 times by 20 minus 40. And so therefore, we can conclude k is equal to negative 3 over 100. And knowing that k is equal to negative 3 over 100, we can therefore conclude h is equal to negative 3x over 100 multiplied by x minus 40. That's the equation of the model. And then the ball passes over the horizontal bar of a set of rugby posts that is perpendicular to the path of the ball. The bar is 3 meters above the ground, and with our equation we have to find the greatest horizontal distance of the bar from O. Well, what we are saying over here is we've got this horizontal post over here, which is 3 meters above, and what we need to do is find out these x values, and once we found those x values we can find the greatest horizontal distance. So let's call this value x1 and this x2. So what we have is the equation when h is equal to 3. We have this equation here, which is equal to 3. And so if I rearrange, we have negative 3x times by x minus 40 equals 300. Negative 3x squared plus 120 x is equal to 300. So 3x squared subtract 120x plus 300 is equal to 0. And with this we can find out what the values of x are. And let's simply use our calculator. We have 3x squared subtract 120x plus 300. So we have a value of 37.3, etc. and 2.67, etc. And so therefore the greatest distance is 37.3 meters. And now we have to give one limitation of the model. Well, quite simply, the model doesn't consider air resistance. Question number 9. We're given that theta is measured in radians, and with this we have to prove from first principles that the derivative with respect to theta of cos theta is negative sine theta. Now we may assume the formula for cos of A plus minus B, and that as h tends towards 0, sine h over h tends towards 1, and cos h minus 1 over h tends towards 0. Now here we've got the formula for first principles, and here we've got the trigonometric identity for cos A plus minus B. That's cos A cos B minus plus sine A sine B. So the first thing we will do is define what f of theta is. We will begin by letting f of theta equal cos theta. And with that, we can therefore find out what f of theta plus h is. That will be cos of theta plus h, which, using the identities, that's cos theta cos h minus sin theta sin h. And so therefore we know that f dash of theta is given by the limit as h tends towards 0 of f of theta plus h minus f of theta over h. So using what we know, f dash of theta then, that's equal to the limit as h tends towards 0 of, well, we've got f of theta plus h, which we've just defined over here. And then we subtract f of theta, which is cos theta, and then we divide this by h. And if we group and factorize, we've got the limit as h tends towards 0 of, well, here we'd have cos theta, and then inside the bracket we have cos h minus 1, and then we have sin theta sin h all over h. So we can split this limit up as the limit as h tends towards 0 of cos theta multiplied by cos h minus 1 over h. Subtract the limit as h tends towards 0 of sin theta multiplied by sin h over h. Now, using what we know here, we know that as h tends towards 0, sin h over h tends towards 1, and cos of h minus 1 over h tends towards 0. So, I've got cos theta times by 0 minus sin theta times by 1, which is negative sin theta. And therefore, with respect to theta, the derivative of cos theta is negative sin theta. Question number 10. A spherical mint of radius 5 mm is placed in the mouth and sucked. 4 minutes later, the radius of the mint is 3 mm. In a simple model, the rate of decrease of the radius of the mint is inversely proportional to the square of the radius, and using this model and all the information given, we have to find an equation linking the radius of the mint and the time. You should define the variables that you use. Well, if we first of all define the variables that we use, we will let r equal the radius of the mint in millimeters and t equaling the time in minutes. And we know that the rate of decrease of the radius is inversely proportional to the square of the radius. So that means that dr over dt is proportional to 1 over r squared. It's inversely proportional to the square of r, which means dr over dt equals k over r squared, where k is a constant, is the differential equation we need to solve. And if I separate the variables and integrate, we have r squared dr equaling k times by dt. And if I integrate, we have r cubed over 3 equaling kt plus c. And we know that when t is 0, r is 5. And we are told this because initially it's 5 millimeters, and that's when it's placed in the mouth. So we have 5 cubed over 3 equals k times by 0 plus c. And so therefore, c is equal to 125 over 3. And so therefore, so far we've got r cubed over 3 equaling kt plus 125 over 3. And we know that 4 minutes later, the radius is 3. So, when t equals 4, r is equal to 3. So I've got 3 cubed over 3 equals k multiplied by 4 plus 125 over 3. So if I find out what k is, I've got 3 cubed divided by 3, take away 125 over 3 divided by 4, so I get minus 49 over 6 for k. So k equals minus 49 over 6. And knowing what k is, we can therefore conclude the solution to our differential equation, we've got r cubed over 3 equals minus 49 t over 6 plus 125 over 3. This is the solution to the differential equation. And for part B, hence find the total time taken for the mint to completely dissolve, give your answer in minutes and seconds to the nearest second. Well, it completely dissolves for part B when r is equal to 0. So I've got 0 cubed over 3 equals minus 49t over 6 plus 125 over 3. 49t over 6 equals 125 over 3. So if I find out what t is, I've got 125 over 3 divided by 49 over 6, and it turns out we get 5.10, etc. minutes. And this to the nearest second, we can therefore conclude the time is 5 minutes 6 seconds. And then for part C, we have to suggest a limitation for the model. Well, we can see then the model assumes the mint stays spherical the entire time, which is unrealistic. Question number 11, we've got 1 plus 11x subtract 6x squared over x minus 3 times 1 minus 2x being equivalent to a plus b over x minus 3 plus c over 1 minus 2x. We have to find the values of the constants a, b and c. So for part A, we begin with the 1 plus 11x subtract 6x squared divided by x minus 3 times 1 minus 2x, and this is equivalent to a plus b over x minus 3 plus c over 1 minus 2x. And if I multiply through by x minus 3 and then 1 minus 2x, we end up with 1 plus 11x subtract 6x squared being equivalent to a times by x minus 3 times 1 minus 2x plus b times by, well, if I times by x minus 3 and the 1 minus 2x, the x minus 3's cancel, leaving me with 1 minus 2x. And with the c, the 1 minus 2x is cancel, so I've got x minus 3. Now, to find the values of a, b and c, we can substitute in different values of x. For example, when x equals 3, now the reason I'm choosing x equals 3 is because the a term will disappear and so will the c term. On the left hand side, I've got, if I substitute in x equals 3, I've got 1 plus 11 times 3 minus 6 times by 3 squared, which is minus 20. And with the b term, I've got 1 minus 2 times by 3, so that's 1 minus 6, which is minus 5. So I've got minus 20 equals minus 5b, in which case we can conclude b is equal to 4. Now when x equals 1/2, if I work out what I get with 1/2, I've got 1 plus 11 times by a half minus 6 times by a half squared, so that's 5. And then the a and b terms disappear, and then I've got a half minus 3, which is minus 5 over 2. So I've got minus 5c over 2, in which case we can see c is equal to minus 2. Now, I can choose any value of x I want now. It's easiest to choose x equals 0, because a lot of terms will disappear then. On the left hand side, I'm just left with 1. On the right hand side, I have a times by, well here I've got minus 3 times by 1, so that's minus 3a. Here I've got b times by 1. And then here I've got 0 minus 3 times by c, so that's minus 3c. Now I already know the value of b and c, so I've got 1 equals minus 3a plus b, which is 4, minus 3c, so that's minus 3 times by minus 2, which is positive 6. So 3a is equal to 9, a is equal to 3. And now that we know the values of a, b and c, we can therefore conclude 1 plus 11x minus 6x squared over x minus 3 times 1 minus 2x, that's equivalent to 3 plus 4 over x minus 3, and then I've got minus 2 over 1 minus 2x. So those are my values of a, b and c. And now we're given that f of x is equal to 1 plus 11x minus 6x squared over x minus 3 times 1 minus 2x, where x is greater than 3, and we have to prove that f of x is a decreasing function. Well, for part b then, we've got f of x, which, using our result to part a, is what we have over here. F of x is 3 plus 4 over x minus 3, subtract 2 over 1 minus 2x. And if I differentiate this, f dash of x is equal to negative 4 over x minus 3 squared, subtract 4 over 1 minus 2x squared. Now, x minus 3 squared, that is greater than 0, and that's because x is greater than minus 3. and 1 minus 2x squared, that's also greater than 0. Again, that's because x is greater than 3. And so therefore, f dash of x, that will equal negative, and the reason we've got negative is because over here, we've got negative 4 over something positive. So that is this result here. And then we've got as well the negative 4 over something again which is positive, and that's this over here. So I've got minus 4 over something positive, subtract negative 4 over something positive. Well, this is always going to be less than 0. And therefore, because f dash of x is less than 0, this would imply f dash of x is a decreasing function. Question number 2. Well, for part A we have to prove that 1 minus cos 2 theta is equivalent to tan theta sin 2 theta, where theta doesn't equal 2n plus 1 over 2 pi, where n belongs to a set of where n belongs to a set of integers. Well, let's focus for part A on the left hand side. We want to somehow get to tan theta sin 2 theta. Now, the way we can approach this, well, so far we've got 1 minus cos 2 theta. Now cos 2 theta, that's the same as 1 minus 2 sin squared theta. So I end up with 2 sin squared theta. Now this is the same as 2 sin theta times by sin theta. Now if I pay attention to what I want to show, how can we get from here to tan theta sin 2 theta? Well, let's write out the right hand side and work backwards. So far I've got tan theta sin 2 theta. Tan theta is the same as sin theta over cos theta. And sin 2 theta, that's the same as 2 sin theta cos theta. So it looks like we have 2 sin theta cos theta over cos theta, which is exactly what we have. So the way we can approach this is to multiply this by 1. So I've got 2 sin theta multiplied by cos theta divided by cos theta. And what we'd end up with then, recognizing that sin theta over cos theta is tan theta, we end up with over here 2 sin theta cos theta times by tan theta, which is the same as tan theta sin 2 theta. And that's exactly what we wanted to show. So the left hand side is equivalent to the right hand side, hence shown. Then for part B, we have to solve for x being in between minus pi over 2 and pi over 2. The equation is x squared x minus 5 times 1 minus cos 2x equals 3 sin squared x sin 2x, and we have to give any non-exact answer to 3 decimal places where appropriate. So for part B, we've got x squared x minus 5 multiplied by 1 minus 2 cos 2x, and that's equal to 3 tan squared x sine 2x. Now sec squared x, that's the same as 1 plus tan squared x. And then I'm subtracting from that 5. And the 1 minus 2 cos 2x, rather here I've just got cos 2x. That result over here is what I've just found to be tan x sine 2x. And all of this is equal to 3 tan squared x sine 2x. So for this bracket I've got tan squared minus 4, and I'm multiplying that by tan x sine 2x, and that's equal to this on the right hand side. So if I multiply out the brackets, I've got tan squared times by tan times by sine 2x, so that's going to be tan cubed x times by sine 2x, and then I've got minus 4 times by tan x sine 2x, and that's equal to this result here. So if I take everything over to one side, I have this result here, subtract this over here, and that's equal to 0. So I can factorise out from each term a tan x and sine 2x. So I've got tan x sine 2x times by, well, I'd have tan squared x minus 3 tan x minus 4 equals 0. So I've got tan x sine 2x multiplied by, well, this I can factorise as tan x plus 1, and then here I've got tan x minus 4, and all of this is equal to 0. So if I have tan x equaling 0, that would imply x is equal to 0, and we're solving in between minus pi over 2 and pi over 2, so I can't find any solutions from that. For the next one, I've got sine 2x equaling 0, so only solution I get over here is x equals 0. And remember, x can't equal pi over 2, so I don't need to find any other solutions after this. And then if I've got tan x plus 1 equaling 0, that would imply x is equal to minus pi over 4. And then if I've got tan x minus 4 equaling 0, that means x is equal to the inverse tangent of 4. Well, let's make sure we're in radians, which is 1.326. And that's to 4, or rather that's to 3 decimal places. So our solutions for x, we've got x equals minus pi over 4, 0, 1.326. That's to 3 decimal places. Question number 13. Figure 2 shows a sketch of part of the curve C with equation y equals x times the natural log of x, where x is greater than 0. The line L is the normal to C at the point E, and the region R shown shaded in figure 2 is bounded by the curve C, the line L, and the x-axis. We have to show that the exact area of R is AE squared plus B, where A and B are rational numbers to be found. Well, what we can do for this is split the area up into 2 parts. I've got this first part, which I'm going to call R1, and the second one, which I'm going to call R2. Now, for me to find out what R1 is, I need to integrate under the curve between this point here and the point x equals E. Now, before we do anything else, what we know already is that L is the normal to C. So with that, we can find out the equation of the normal L. And we can do that by differentiating. We know that y is equal to x times the natural log of x. And if I differentiate this, well, to differentiate I need to use the product rule. U is equal to x, u dash is equal to 1, v is equal to the natural log of x, v dash is equal to 1 over x. And so therefore, if I find out what dy over dx is, dy over dx equals natural log of x times by 1 plus x times by 1 over x. And it turns out dy over dx then is equal to natural log x plus 1. Now, if I substitute in the point P, which is EE, into dy over dx, dy over dx is equal to natural log of E plus 1, which is 2. What does this 2 represent? Well, it would represent the gradient of the tangent. And so therefore, the gradient of the normal is the negative reciprocal of this, which is minus 1/2. And so therefore, the equation of the line L, we have y minus e. Well, let's just move this over here. At the point E, the equation is given by y minus e equals minus 1/2 times x minus e. So, when y is equal to 0, we can find out where L crosses the x-axis, and when x is equal to 0, we can find out where it crosses the y-axis. So, if we attempt to solve when y equals e, rather when y equals 0, for L, we have 0 minus e equals minus 1/2 times by x minus e. And in this case, x is equal to 3e. Because if I multiply by 2, I have minus 2e equals minus x plus e, and if I rearrange for x, I get x equals 3e. So if I add that to my diagram, that means here I've got the point 3e, 0. And if I consider the curve C and set that equal to 0, I've got 0 equals x times the natural log of x, which implies either x is equal to 0 or the natural log of x equals 0, which implies, well, if I've got x, the natural log of x equaling 0, that implies x is equal to e. Rather, that implies x is equal to 1. So the point over here is 1, 0. So that's that point, this is this point. Now, what I need to do to find out the area of R1, I need to integrate between 1 and e of x times the natural log of x. So, to find out what the area of R1 is, the area of R1, that's equal to the integral from 1 to e of x times by the natural log of x dx. Now, to do this, I need to use integration by parts. So if I say that u is equal to x, u dash is equal, rather if I say u is equal to the natural log of x, u dash is 1 over x, and if I say that v dash is equal to x, that means v is equal to 1/2 x squared. So if I continue to work this out, the area of R1, I've got v times by u, so I've got 1/2 x squared times the natural log of x, and that's in between 1 and e. Subtract the integral from 1 to e of v times u dash, so I have here 1/2 x squared times by 1 over x dx. So, in terms of what stays the same, this bit stays the same, and then I subtract the integral, and here I have 1/2 x dx, which I need to integrate. So, this bit stays the same, and then if I integrate 1/2 x in between 1 and e, that means I need to evaluate 1/4 x squared in between 1 and e. So combining all of this together, I've got 1/2 times x squared times the natural log of x, subtract 1/4 x squared between 1 and e. So, if I substitute for my upper limit, I've got 1/2 e squared times the natural log of e minus 1/4 e squared. For my lower limit, I've got 1/2 times by the natural log of 1. Subtract 1/4 times 1 squared, which is just 1/4. And if I work all of this out, it turns out we get 1/4 e squared, and here natural log of e is 1. So I've got a half, so that's where the quarter comes from. And then I add on to this 1/4. Now the area of R2, hopefully you'd find we have a triangle from e to 3e, that's the base of 2e, and the height is e. So that means the area of R2 that's 1/2 times e times 2e, which is e squared. And so therefore the total area I have the area of R1 and I add on the area of R2, and it turns out we have 5/4 e squared plus 1/4. A is 5/4, B is 1/4. Question number 14. A scientist is studying a population of mice on an island. The number of mice n in the population t months after the start of the study is modelled by the equation n equals 900/3 plus 7e to the minus 0.25t, where t belongs to a set of real numbers and t is greater or equal to 0. For part A, we have to find the number of mice in the population at the start of the study. Well, for part A, so far we know that n equals 900/3 plus 7e to the minus 0.25t. So, knowing that, what we have to do for part A is set t equal to 0. That leaves me with n equals 900/3 plus 7e to the power of 0, which is equal to 900/10, which is 90. Now, for part B, we have to show that the rate of growth dn/dt is given by dn/dt equals n times 300 minus n over 1200. Well, if I call this equation 1, for part B, I'm going to rewrite equation 1 as n equals 900 times 3 plus 7e to the minus 0.25t to the power of minus 1. And the reason I want to do this is because I can now use the chain rule to find out what dn/dt is. So dn/dt, I've got here, I need to times by the power, so I've got minus 900, and then I subtract 1 from the power, so I've got 3 plus 7e to the minus 0.25t, then I to the minus 2, and then I times by the differential of the bracket. Now if I differentiate the bracket, I have 7 times by minus 0.25, which is minus 1.75. So I times this by minus 1.75 e to the minus 0.25t. So I'm just using the chain rule there. A minus 900 times minus 1.75, that's equal to positive 1575, and then I've got the e to the minus 0.25t, and I multiply this by 3 plus 7 e to the minus 0.25t to the power of minus 2. And I'm going to rewrite this as 1575 e to the minus 0.25t divided by 3 plus 7e to the minus 0.25t squared. So let's call this equation 2. Now do you notice that our dn/dt does not contain anything involving e's? So we need to get rid of everything involving the e's. So if I take a look at equation 1, from equation 1 we can see that 3 plus 7 e to the minus 0.25t is equal to 900 over n. And so, therefore, 7e to the minus 0.25t is equal to 900 over n, subtract 3, and we will leave that as it is. We'll call this equation 3. And if I take a look at equation number 2, I can rewrite that to say that dn over dt equals 225 times by 7 e to the minus 0.25t, because 7 times 225 gives the 1575, and then on the bottom I've got 3 plus 7 e to the minus 0.25t squared. And so if I substitute into equation 3, this equation 4 into 3 dn over dt, that's equal to 225 multiplied by, well, this 7e to the minus 0.25t, that's 900 over n, subtract 3. And then I divide this by 3 plus 7e to the minus 0.25t squared. Now that result is what I said. That's what I have over here. That's 900 over n. So I divide this by 900 over n squared. So now I need to tidy all of this up somehow. So I have 225, and then here 900 over n subtract 3, that's going to be the same as 900 subtract 3n over n. And on the bottom I have 900 squared over n squared. Now what we can do is multiply through by n squared. So if I do that, I've got 225, and then here well, if I times the top and bottom by n squared, then this and this cancel, and this cancels with this once. So we have 225 times by n multiplied by 900 minus 3n divided by 900 squared. And if I take out a 3 as a common factor, I've got 225n multiplied by 3 multiplied by 300 minus n over 900 squared. So if I work out what this is, I get 1 over 1200. So therefore, dn over dt is equal to n multiplied by 300 minus n over 1200. So that's what dn over dt is. And now for the next part, the rate of growth is a maximum after t months, and we have to find, according to the model, the value of t. Before we do anything else for part C, I'm going to rewrite dn over dt as 300n subtract n squared over 1200. Now, we are told from the question that the rate of growth is a maximum after t months. So, we have a maximum at d squared n over dt squared equals 0. And that's because we've got a maximum rate of growth. So dn over dt represents the rate of growth, and because we've got a maximum of that, we need to differentiate that and set that equal to 0. So in other words, what we are saying over here is d over dt of dn over dt is equal to 0. This is a stationary point, and d over dt of d squared n over dt squared finds the nature of the stationary point. So if I differentiate this again, that finds me the nature of the stationary point. So we need to be a bit careful here. Because I've got the rate of growth and I've got the maximum of that, I've got the second derivative, which is equal to 0. So now, if I actually find out what d squared n over dt squared is, I get over here 1 over 4 subtract n over 600. So in other words, I've got 1 over 4 subtract n over 600 equaling 0, in which case we can solve for n. N is equal to 150. So what does this mean? Well, it means that the maximum occurs at n equals 150. So if I go back, what I can do now is set this result over here equal to 150. So, with n equaling 150, I've got this result, which is equal to 150. So 3 plus 7e to the minus 0.25t equals 6. 7e to the minus 0.25t equals 3. E to the minus 0.25t is equal to 3/7. Minus 0.25t equals the natural log of 3/7. So t equals minus 4 times the natural log of 3/7. And so therefore t equals minus 4 times the natural log of 3/7, which is 3.39 months. And then for part D of the question, according to the model, the maximum number of mice on the island is p. We have to state the value of p. Well, essentially, we're looking at where dn over dt is equal to 0. That gives us the maximum number. So, for part D, with dn over dt equaling 0, we've got n times by 300 minus n over 1200 equals 0. N is either equal to 0 or 300, and so therefore the maximum number would be 300.